All right, let's dive into a question that honestly sounds like it's straight out of a sci-fi movie, but it's happening right now. Is AI getting, well, too good at math?
I mean, it's a question a lot of us are asking, right? It feels like every single day AI takes another huge leap forward, and you can't help but wonder, where does it end? Are these things getting just a little too smart? And nowhere is this more obvious than in, of all places, mathematics. You've got these top AI models, think Gemini and GPT, and they're just breezing through problems from high-level math competitions. You know, the kind of stuff that would make most of our heads spin. They're getting the right answers time and time again.
But, and this is the big but, does getting the right answer actually mean it understands the problem? You know, is it really reasoning its way through, step by step, like a person would? Or is it just using some incredibly fancy pattern matching to kind of get lucky? That's the mystery we're going to dig into. So, here's our game plan. We'll start with how AI even takes a math test. Then we'll look at something called the logic map. We'll unpack the difference between being perfect versus just correct. We'll see what the report card actually said. And finally, we'll talk about what this all means for the future. Let's get to it. Okay, so first things first. How do you even test an AI's ability to reason? Well, you basically treat it like a student. You give it a math test. And just like your old high school teacher, you don't just want the final answer. You want to see the work. And that means the AI has to show its work. In the world of AI, this is called chain of thought. The model literally writes out its step-by-step process before spitting out the final answer. In theory, this should give us a perfect window into its brain. But yeah, there's a catch. See, as the researchers behind this study point out, even when the AI shows its work, it's a mess. It's just this big, unstructured jumble of text. It's not a clean, logical proof, and that makes it almost impossible to tell. Was that a brilliant line of reasoning, or just a long, rambling walk that happened to end up in the right place? So, to fix this, researchers came up with a pretty clever new tool. It's a way to diagram the AI's thinking, and they call it the logic map. Think of it as a much stricter, more visual way to grade the AI's homework. So, what exactly is a logic map? Okay, the super technical term is a directed acyclic graph, or DAG. But let's not worry about that. Just think of it as the ultimate all-knowing flowchart for a math problem. It literally maps out every single possible valid step you could take, from the very beginning of the problem all the way to every possible answer, the right ones and the wrong ones. And here it is. This is the actual logic map for that problem we just saw. Pretty cool, right? Each one of those little circles is a piece of information. The arrows show you how one thought logically connects to the next. And you can see how it all branches out, with some paths leading to the right answer, that's the green one, and others leading to a dead end, in red. Let's break this down real quick. The map basically has 3 sections. At the top, you have the inputs. That's just the facts given in the problem. Then you've got the big middle section, the reasoning steps. This is all the math and logic. And at the bottom, you have the answers, all the places you could possibly end up. Okay, and using this map lets us see something absolutely critical. It shows us the difference between an answer that is simply correct and one that comes from what we'll call perfect reasoning. All right, check this out. This is the key difference right here. On the left, we've got an AI that gets the right answer. But look at its path. It's messy. It goes down dead ends, tries out irrelevant ideas, and eventually just stumbles onto the solution. But on the right, that's perfect reasoning. It's a clean, direct, efficient path. No wasted moves, just a straight shot from the problem to the right answer. And that distinction gives us a whole new, much more powerful way to grade these AIs. We're not just asking, did you get it right anymore? Now we can calculate a perfect score. The researchers call it the perfect reasoning rate. It's a score that measures how often the AI gets the right answer by taking one of those flawless, perfect paths. Okay, so we've got this new, much tougher way of grading. The big question is obvious, right? How did today's best AIs actually do on this new test? Let's see the results. And the results are, well, they're pretty fascinating. Take a look at this chart. Each line is a different AI model. Way over on the left, that's the old score. Just, did it get the right answer? And you can see they do pretty well. But as you move to the right, we demand more and more logical perfection. And just look what happens. For every single model, the score absolutely plummets. The takeaway is clear. Getting the right answer is one thing, but reasoning perfectly to get there, that's a whole different ballgame. And it's incredibly rare. Let's put some hard numbers on this. Let's take a top model, Gemini 1.5 Flash. On a tough math test, it got the final answer right about 52% of the time, which, sounds pretty decent. But when they graded its thinking process using this new method, its perfect reasoning score was only 17%. That is a huge, massive gap between getting the right answer and actually thinking the right way to get there. And the researchers found a really clear pattern in how these AIs were thinking. This table basically lays it out. The perfect solutions? They're the shortest, most direct, around 23 steps. The solutions that were correct but messy, they took a few more steps. And the ones that were just plain wrong, they were by far the longest and most complicated, which really suggests the AI just got lost. It was wandering around, exploring way too many dead ends. And that right there is the key insight. When these super smart AIs fail at a hard math problem, it's usually not because they messed up a simple calculation like 2 plus 2. Nope. It's because the logic map of the problem itself was too big and complicated, with too many branches, and the AI basically just got lost in the woods. It couldn't find a clear path through. So, what do we do with this information? What does this all mean for the future of AI and for the people building it? Okay, so let's boil it all down. What are the big takeaways here? Number one, and this is the most important one, getting the right answer is not the same as real reasoning. Number two, we now have a much better grading system for AI intelligence. Number three, this helps researchers figure out exactly why an AI failed, not just that it failed. And finally, this could change everything. It means we can start training AIs not just to spit out answers, but to actually think logically. And that leaves us with one last and pretty heavy question. We're getting ready to hand over some really important high-stakes decisions to these AI systems. But if an AI can't perfectly show its work, if it can't prove its logic is flawless, how much should we really trust it? That's something we're all going to have to figure out.